Okay, I have a question from Chapter 1, Section 3. And it asks to find the constants m and b in the linear function f of x equals mx plus b, such that f of 0 is 2 and f of 3 is negative 1. Now, this is a very simple, and you've done problems like this before, but what makes this a little more complicated is that it's written in function notation instead of in linear equation notation. So you shouldn't be frightened by that. F of x equals mx plus b is just the same as y equals mx plus b. It's just written in function notation. So if it's helpful for you, you can go back to y equals notation. That's fine. And we're given 2 points. F of 0 equals 2. Well, what that means is that when x is 0, f of x is 2. Remember, f of x is simply y. And that means we have the point 0, 2. Then we also have the point x equals 3 and y equals negative 1. So what we're really looking for is we're looking for the equation of a line that passes through the points x is 0, y is 2, x is 3, y is negative 1. And we go back to what we've been doing all along, which is find the slope of that line first. So our y2 minus y1 is negative 1 minus 2, and our x2 minus x1 is 3 minus 0. So you should see that that's going to give you negative 3 over 3, and that's equal to negative 1. So we have m equals negative 1. So now I have a slope and I have a point. I have 2 points. I can choose either one. I'm going to use the y. I could use the point slope formula, but if you recall that b is the y-intercept, that's the value of y when x is equal to 0. Well, we actually have the value of y when x is equal to 0, and that's 2. It's given to us. So really the shortcut to this problem is to say the equation is y equals negative x plus 2, where negative x means it has a slope of negative 1, and the y-intercept, the value when x is 0, is 2. So I'm going to go through this the other way. That's really the shortcut there. Now I could use the point slope form of a linear equation. Y minus y1 is equal to m times x minus x1. And I know that m is equal to negative 1, and I can use either point. So I'll use that point 0, 2. So I get y minus 2 is equal to negative 1, or negative the quantity x minus 0. When I multiply the right side out, I'm just going to get negative x. And when I add 2 to both sides, I'm going to get y equals negative x plus 2. Okay, so either way I get the same answer there. You don't need to go through all the steps, but if you do, that's quite all right. And if you don't, and you see that you have the y-intercept there and you can just plug it into the slope-intercept form, that's fine also. So in problem 15, an office building worth $1 million when completed in 2005 is being depreciated linearly over 50 years. What will be the book value of the building in 2010 and 2015? Assume that the scrap value is 0. Well, we start off with 2 points. At time t equals 0, it's worth $1 million. But in 50 years, at time t equals 50, it's worth $0. So the value goes down $1 million in 50 years, and we divide negative 1 million by 50, and that means it's going down in value $20,000 every year. Well, we started in 2005, and 2010 will be 5 years later. We started with $1 million. We subtracted $20,000 a year for 5 years, which is $100,000, and we end up with $900,000. In 10 years, 2015, we had $1 million minus 20,000 times 10, and that's $800,000.